things in your name, Lord. Didn't I wear the little stripes and fly airplanes? In the name of Jesus.
I feel like it's a call for character. You're a representative, an ambassador. You're here to exemplify what Jesus taught us and to live out the way that He chose to live. And we feel like we're doing that. What kind of name are we bringing to Him here on earth?
I feel like oftentimes, even myself, I can't pick on you, right? Pick on myself, that we serve the Lord as a job interview, like, hey, if you'll do this and this is a benefit package, Lord. If you do this and this for me, then I will go to the deepest, darkest jungles of wherever. Timbuktu, which is actually a mountain, but anywhere. I'll go wherever for it. But sometimes it's like, is that really doing the Lord a favor? And He's like, oh wow, you're so gifted for Timbuktu. Sure, I'll send you there. It's not it. It's like, man, I made you. You don't think I know what I made you for? And I think that's where it comes back to service, Lord. You know me, you made me, you gifted me. And now, Lord, I'm here to send you. I think that's real love. All right, a little lighter, more historical and worldly. Whoa, you ready? 2 of them. Oh, no. Psych. All right, go back here, Lord. There we go. Always, General George Patton, always do more than is required of you. Okay? Sometimes we always get by with the very least. I've watched airplanes come out of annuals with DNA all over the side of it. Fingerprint of grease all over the side of it. Wipe it off, clean it off. It takes another 5 minutes, little things like that. All right, a pint of sweat will save a gallon of blood. What does that mean in our business? Or our job? Yeah. You know what? It's good enough. Ouch. Ouch. I was telling Brian or somebody yesterday, I was telling about, I had the airplane they brought in and I was looking at it, and the previous mechanic had duct taped where the pedals go through for the steering linkage. And that's #1 cause of death in small aviation is carbon monoxide in the cockpit through your steering boots. And all it is Kevlar. It's a Kevlar fabric that, goes around and it's supposed to latch. But they're notorious for cracking them. Not about. You took 5 minutes to duct tape that. Like, man, I sure hope the duct tape seals off the air, or the carbon monoxide from the exhaust. So, you start listening to that. Why don't you just tell the owner, hey, spend $70, we'll get new ones. NTSB report came across my desk yesterday afternoon. I kept reading it. There was a 60-year-old man that took off. He was 368 pounds over gross and 3.5 inches outside of CG. And wondered why he ran out of fuel an hour short of his destination. Going a whole lot slower than you
said it flew though.
It flew, but he actually, everyone's life ended because he had calculated it based on what he normally flies by himself, not with 6 passengers. Full gross, limited fuel, so actually ended all their lives. Think about that, like, was it really that difficult to sit down and do a calculation for weight and balance? And you're like, man, yes! It took forever in Christina's class. But it actually ended all 6 of their lives. So, let's be diligent with our work, do the best possible job that we can. All right? So, what's this morning? Is that what you're getting ready to ask me? So I want us to go out and finish our wheels and tires and balance them. If it doesn't balance and I have another tire, yes, you can switch it. I have a question though. We'll pick on Corbin because he's lively this morning. So Corbin, you're trying to balance a wheel and tire, and it's like Mr. Leo's over there, which has Leo and Lee, right? Leo and Lee. Yeah. You have, I don't know, 25 weights on it. At some point, the logic kicks in, and what would you think, Corbin?
Probably couldn't use that tire.
Not use that tire? What else could we do? Okay, I'm on the mission field, and it takes me 3 weeks to get another tire. What could you do? Rotate the tire on the wheel. Okay? Yes, you have to deflate it. Yes, that takes an extra minute. To deflate it, squish it, and then move it slightly around. But yeah, you can actually rotate it a little bit. So put a mark, a little dot on the wheel, and you rotate the tire just slightly. Trying to get away from that. You can rotate it sometimes 180 degrees, or sometimes you have to do just 90 degrees. I've had to do 2 and 3 times to get it to where it will actually somewhat balance. Most of those are retreads. Who has a retread in here? I think Corbin had a retread. Trevor, you had a retread. Yours is the monster. Yeah. Probably the most common retread among flight schools. All right. So this morning I'd like to knock that out. The goal is to get back in here roughly by 9, but if we don't make it by 9, might be 9:30. We're going to have to do a few switcheroos. Today is like a warm spring day in Michigan. Not really, but we're going to have to do a switcheroo on some of the planes to get, because I want groups 2 on brakes, which will start tomorrow morning bright and early. We're going to hop right into brakes, moving brakes apart tomorrow. So I'd like to get through the lecture on that today, or really close to it. So let's aim for 9 o'clock, about an hour 40 minutes, for you to be able to try to finish your wheel and tire and then down jack the aircraft, okay? If it doesn't work, it's okay. We'll get to it at 9:30 then. All right, any questions? All right, you are staying in this group for bleeding brakes as well as oleo struts, but you will get different aircrafts. I will rotate you. So if you're working on a Cessna now, you're probably going to work on a Piper. So I want you to be able to see all the different types of landing gear. In order to be a good mechanic. All right. So let's hop into brakes real quick. I think Anna wants to be done pretty quick, so we can move the planes around and get started for tomorrow. So as you already know, we have already experienced most typical brakes. I have to say typical, because you're still going to see some of the old dinosaurs that are still around. But typical brakes are going to be like this. Here we have a caliper or a cylinder housing. Most of the time we just call caliper or brake assembly. Okay? So you go to the Cleveland manual and it will tell you what that brake assembly is. Be able to torque those bolts to the back plate. What are they called, Mr. Miller? The torque for these?
What is the torque code?
No. What is this called in the Cleveland manual?
The bolt?
Yep. What's it called? If you're looking for the torque, tie bolt torque. I know, could they come up with an easier name? Yes. And so in order to find that torque, what do you have to do? Hop on one leg. No, it seemed like, it feels like that. So you have to go to the big Cleveland manual to figure out what brake assembly you have. Unless you already know. Then you have to go to the quick reference guide to look up what the back plate tie bolt torque is. Okay? This is a dual piston cylinder. Okay? What does that mean? Yeah.
My brakes had a sticker on it with the torque of the backplate bolts. Is it the
That's
same?
awesome.
Is that the same as the wheels where that just wears off?
Oh,
Like,
yeah.
do they all come with that originally?
Yeah, yeah. They do come with it. They usually last a year or two, and that's it. So that's how you know it's a Cleveland. It's supposed to have a sticker if it's not stamped, okay? So, these are also, oftentimes, the old ones are magnesium. Wait a second. We're heating up on landing. Sounds like a potential fire, doesn't it? So this is one that has been well used. Inside, on this, you'll have a line to the brake. And then if it's a dual, Mr. Yoder, you guys had dual cylinders, right, on the Aztec? And so, because it was heavier load, so they would have another line over to the other cylinder. And then from there, you'll have a bleeder valve. What's the bleeder valve look like? It looks like this one right there on the bottom, okay? So, the brake fluid comes in, 5606, and as you push the brake, it pushes the two pistons out. Okay, at the bottom, we will open it to bleed it. Only to bleed it. But as you push on your pedal, then the pistons come out and push against the back plate here and squeezes that to the brake assembly onto the linings. Okay, the linings then slow the aircraft down. Any questions so far? Kind of a general idea. I'm going to pass them around so you can look at it. Okay, these two. This one definitely failed inspection. Okay, very porous, lots of holes in it. Okay. All right. Oh, I did want to do a quick overview on this. So this is if you're buying tires from Goodyear. Yeah, go ahead, Corey. Some of the aircraft, they're on the top. A lot of aircraft, they're on the bottom. And if you force it hard enough, eventually everything will come out. But we have options to bleed it different ways. Yeah. Because in a car, you're normally going to just fill up the well, it's a boosted brake system. You're just going to fill up the reservoir at the front. And you're going to push the brakes, somebody's going to open the bleeder, right? Yeah. And so in our system, you can do that, top down, but normally we'll do a bottom up as well. So it's really nice to do it. From the bottom. Yeah. All right, so if you're looking for a typical, you've got to buy a tire for your aircraft, okay? Let's just do the simple ones, okay? The top category, 5-5. How many of you had a 5-5 tire? Dan, raise your hand. Okay, good. And Gavin, good. Mr. Finney, anyone else? All right, so 5-5 is typical Cessna nose tire, okay? Typical. Unless you get to a 206 or something big, right? So small Cessnas, but notice the ply ratings. What is a ply rating insinuating? The strength of it, okay? So we have 6 ply or 10 ply. But then you get over to the rated load in pounds. Rated load in pounds goes from 1,200 to 2,100. Okay? It's a big difference. So you can't just grab a 5-5 tire and say, let's just send it. Okay? Because if the aircraft's 1,400 or 1,500 pounds, you've got to already anticipate that at some point the pilot's going to drive it home. Okay? We got a 1,500-pound aircraft hitting a nose tire on landing, and you've only got a 1,200-pound load rating tire on there. Okay? they're gonna drive that oleo strut right into the ground, okay? Everybody kind of get where I'm at? So please make sure you're matching the tire to the rated, or what is rated for that aircraft, okay? Goodyear's super good about selling you the right tire. Hey, I have this aircraft, notice here, braking pressure 3,400 on some of the 6.6s, okay? Where would I want a 3,400 pound? Probably on something like the Apache. Make sure I can stop that load. Versus the Bonanza wouldn't need a 3,400 load. You could get away with probably a 2,500 pound load. See what I'm saying here? We good? So please know what aircraft you're working with. Make sure you get the right loaded tire. Okay, brake systems. Brake systems. How do brakes yes, sir?
For those load rates, is correction harder compound with a higher load, or do you guys use a higher load rating later?
Sometimes, yes, sir. Yep. Because it would be a little heavier or harder. Yep. Yeah, and even think about it. If your wheel is a soft aluminum, use a hard fly rating. You know, the tire may not give if they made a really hard landing. Maybe the wheel would crack instead. Okay, so how do brakes operate in your car? How do brakes operate in your car? You know? Yeah.
On the pedal, pushing on the master cylinder.
Push on the pedal and it pushes on a thingy called the master cylinder. Is that what it is? Is that really what it is? The master cylinder? Master cylinder. It's not a brake boosted or booster brake system?
Well, it is, but it's boosted, but no, it's still direct connected to the master.
Yeah, so it's sending fluid, but then you get a kick in the pants when the car's running, right? And it helps to add more pressure to the brakes, okay? Well, in aviation, we have all types of different brake systems, okay? All types. So we're going to hit just a few. We're going to hit the basic ones, and then we'll get more complex. Not today, but just basics today. Brake system overview and different brake design. So we should understand the brake system and understand the operation of the caliper versus the disc. Okay, problem with brake system, here we go. Somebody turn this all the way down, dude. What in the world?
And as we came in for a landing, the plane that I was in flipped over.
You okay? Yep. Unhook your belt.
As you would imagine, it happened very quickly. And suddenly we were upside down lying on the runway, and And as we came in for a landing, the plane that I was in flipped over.
You okay? Yep. Unhook your belt.
As you would imagine, it happened very quickly. And suddenly we were upside down lying on the runway, and the pilot and I made sure that
Sometimes brakes lock up. Very sad. Okay, so how do brakes actually operate? So you're going to push the brake pedal. Okay, typically it is where on your aircraft? Huh? Top of the rudder pedals. Yes, sir.
So for like, it would only flip over like that if it was a tail wheel aircraft, right? Because if it was train style, the brakes would be in the back, right?
Yeah, but I mean, depending on how they brake, there has been an occurrence where they can actually tip this way if they really get on the brakes. They can actually tip sideways, and then it plane sits kind of wing and prop into the ground. It happens. It happens. Okay, So you're gonna push on the brake pedal, okay? Old style brakes were hill brakes. You may ever flown a hill brake aircraft? Okay, Taylor craft, yeah. Old Piper Cub, that's when I got my aerobatics, was in a Super Cub, and it was all hill brakes. And it was super tricky transitioning from toe brakes to hill brakes. Cause it's like, oh no, I wanna push the rudder. No, that's the brakes. And it got a little tricky sometimes. So, some aircraft will have a reservoir above it, and so as they push it, the reservoir automatically fills, and it transfers that energy to the brake caliper, and then out to the piston to push onto the brake lining. Okay? Brake lining. Very simple. That's like elementary how brakes work. You need to understand that. Any questions on this? How a brake actually operates? Okay. I'm assuming then, from here on out, you understand the basic operation of how a brake works. Push the pedal, sends fluid, transfers that energy from your pedal out to a caliper. Caliper inside there is a piston, pushes on the back of a piston, and it closes or squeezes that lining. Okay? So here's a couple different types. We have a reservoir type. Here is the brake pedals. You push the pedals, right brake comes down, okay, park and brake valve may be there, and then here's our spinny thing called the wheel and tire, and the brake disc squeezes that brake disc, okay? And they make Goodyear brakes. That
Calipers on the inside, ain't it?
Okay, I guess you're, no, wait, it's not on the axle. Axle would be right here, bam. And let's not talk about Goodyear brakes here. So, dual master cylinder system. Pilot's got some brakes. Oh, and guess who else? Co-pilot gets brakes. Okay? Instructors really like this style. First aircraft I flew, I was 15 years old, and only the pilot side had brakes, and he's like, man, you know what you're doing? He was super nervous, but you know what? I'm here today, so I guess the brakes worked. So, as the pilot pushes on brakes, notice the difference in the brake master cylinders. What do you notice? Any difference there?
One has a reservoir.
One has a reservoir, or one's a little chubby up here. Okay? So, we've got one like this. Bam! And you got one like this. Bam! Okay? Make sense? Okay. That's all it gets. That's all the fluid. That's all the reservoir. Why? Why do we need such a small reservoir?
If it ain't supposed to run a lot.
No, you don't really need brakes until you land. Right? We don't use tires very often. Right? We don't use brakes. So, the pilot then pushes on, and then he comes in the inlet, and then out the outlet down here. Okay? I can't think of an aircraft that would run this system. Piper runs it opposite, where they have a reservoir up here, runs the co-pilot, then over to the pilot. Then the pilot has direct down to the brakes. Better system. Because now, as the pilot pushes, it's got to push it through the co-pilots and then down to the brakes. See that problem there? So, if I have any air in the system, it's going to show up. Okay? Right. Yes, sir?
That symbol, it's a diode symbol.
It's a parking brake symbol there. Yeah.
Would the co-pilot's pedal go down then? Because it should be moving that actuator in a sense, or no?
No, so the piston is going to be right up here, somewhere up here in the top area, and it will allow fluid to push through, to transfer through. And so the piston's usually sitting right up here. Okay, this one's actually opposite, whatever. So it's going to allow the fluid, Piper goes like this as you push. So then fluid comes in here, the piston sits up here at the top. And so you're pushing on it directly. So it's not moving the piston in here, just allowing the fluid to move in and out until you push. And then it comes up to where the fluid is and pushes on the co-pilot side. So the pedal actually doesn't go down. Cessna usually only does, if they do dual brakes, they usually do one master cylinder on the pilot and one master cylinder on the co-pilot. How does that work? Yeah, so they'll run a linkage. They'll run a reservoir on this side and a reservoir on this side and a reservoir on this side. So then this linkage for the right brake comes over to this one, direct linkage, and then a reservoir from this side runs to there. Okay? Sometimes they'll run it that way, or they'll run just two reservoirs here and then direct linkage to the co-pilot so that when you operate it, it's operating the same master cylinder. Okay? Any questions on that? I'll pass these around in just a second. Did you guys already look at the open view side? Like an open style? Okay, I'll pass this one around. The reservoir is above the O-ring there at the top. All right, brake flow chart. Okay, this is a typical Piper. Okay, the only difference is the parking brake is above the co-pilot pilots. Parking brake is before in a Piper system. Okay, I will give one group or two groups the Piper system this year. Okay, because I want to teach through it. Yes, it is hard to do, but I want to teach through it. So in this system, we have a reservoir. The reservoir is filling the master cylinder. As co-pilot pushes, where does it go? Over to the pilot side, and then out pilot side down to a parking brake, or actually directly to the caliper on a Piper system. Okay? So that way the pilot has direct control. Okay? That's actually a better system. The way the pilot has direct braking. One of the functions of the brake system is to absorb heat energy developed during braking. The majority of this heat is absorbed by brake disc. Get this. Some tires actually have weep holes that as they get too hot, they will have a fusible plug that will actually release that heat. Why is that? Not seize. Well, maybe it'll seize. That would be on the brake side. But it's rubber. And as they heat up that tire, there's a great chance of flammability. Oh no, the tire's super hot. Now they'll release a fusible plug so that the tire does not catch on fire, and that plug will go out and release it so that the heat doesn't cause, or the heat energy doesn't cause the tire to catch on fire. The large mass of the disc, okay, so the majority of the heat is absorbed by the brake disc, so it's spinning. The large mass of the disc, the more heat energy is able to absorb. A well-designed brake system will provide adequate disc mass without excessive weight. So we have very thin disc, okay? Very, very thin disc. Even on larger aircraft, for example, the Beach Jet. The discs themselves are very, very thin, but there's multiple ones so that it can dissipate that heat. Yes, sir? Ceramic, affirmative. Yeah, Rapco, we do not use asbestos a whole lot in newer stuff anymore. Most of them are ceramic, yeah. No, they're still oftentimes chrome or steel disc, but ceramic linings. The kinetic energy required to stop an aircraft is a function of mass weight of the aircraft multiplied by the square of its landing speed. So your speed has a lot to do with your braking distance, okay? A lot of aircraft owners like long rollouts. Why is that? Saves your brakes. You have more asphalt, which gives you more drag so that you don't have to use as much brake system. Okay? So types of brakes. Man, here's a standard brake style. They're not usually this clean in aviation, but we have a multi-disc brake where you have a series of stators and rotors, multiple linings and rotating with the wheel. And then as you squeeze it, it squeezes all of them together. Okay? Over here we have a single disc attached to the wheel, and the floating caliper. Is this single or dual? Dual piston. We have dual pistons here, and it's squeezing. It has a lining on this side and a lining on that side, squeezing that disc. Okay, one of our favorites here, okay, is an expander tube. Anybody ever worked on one of these? So what?
Yeah,
So-
on the four-wheeler.
On a four-wheeler. So you have all these are pure, not pure, mostly pure asbestos, okay? Disc here are linings, and inside is a tube. And so as they pushed on the brake, it would push out on that rubber tube like a balloon, and it would push on the wheel inside to stop it or slow it down. Expander tube.
Kind of like drum brakes, in a sense.
No,
Isn't that the same as pushing off on the brake pads?
this is a drum brake. A little cute drum brake. Okay, so as you push on a drum brake, push here, and then it pushes on a little cylinder. And then these come out and slow it down. Versus expander tube, the whole tube is filling. The whole giant tube is filling, literally like a rubber balloon. DC3s use this. This is off an old mall. So when I pass it around, it says Jackson, Michigan, which is where mall was until they almost bankrupted. Then he flew it out of the hangar, in Jackson, Michigan, and immediately had enough business for the next 30 years. Yep.
Picture on the right, is that right?
This is a drum brake, yep. And this is an expander tube. So we have a drum brake, expander tube, and drum brake style. Drum brake off a Chevrolet truck or old Ford truck, where it pushes on both sides and it slows it down. This is one off an actual aircraft here. So as you push on it, what does it do? It gets hung up. No. Go ahead.
Drum brakes do exist on airplanes?
They do, yep. This is an actual, and notice there's no adjustment like there is on a Chevrolet, okay? You just keep pushing harder if it doesn't stop, right? Now, you have direct linkage. Taylorcraft doesn't use hydraulic fluid, but they use drum brakes with a cable. Yeah, so they have a cable connected here, and that cable is adjusted over time. You gotta keep tensioning that cable up as the brake disc wears, okay? So this is a brake disc, and that would be an expander tube style. Okay? Any questions on these two types? DC3 still uses expander tube type. I have one, and it's about 40 pounds. Pretty wild looking. That's inside the wheel itself. Okay? All right, let's move on to Brian's favorite. Everybody ready? Drum roll, please. Oh, yay! Okay, so we have the historic one here called. Oh, it's up here. We have the historic one called the Goodyear brake system, which there are still some out today. They have not been made since sometime in the 70s. Sometime in the 70s, they quit making Goodyear. So the way this works is you have a floating disc. The disc is made to float. This looks like a gear. It's really not. It's actually the point of floating for this Goodyear brake disc. And what is stationary is the actual caliper. And the caliper is then directly bolted to the axle. So as the wheel spins, then you push on the pedal, and it pushes out this little tiny cute baby asbestos brake lining. I'll pass it around. It's still in there. You'll look at it. And that's what stops it. Okay? Why did they stop these? Anybody have an idea of why they stopped making these? They would seize notoriously. So, you take off, and maybe you're on a grass strip, and it was a muddy day. And now you got all that garbage where? Right around your brake disc. Well, then you turn around, you come back to land. Okay? And if it was a great sunny day in Michigan, it was probably below 30. So all that ice then froze at altitude. So now you're coming back, a little salty about it, but coming back to land. Now the brake disc is no longer a floating brake disc, is it? Come back to the land, and immediately the brake disc doesn't float. It stays right where it is, slightly cockeyed. And so people were ground looping aircraft because their brake disc would be frozen, maybe one side or the other. You say, well, if you land it fast enough, it'll heat up and burn off the ice. Yes, but you don't think about that. It's like, well, maybe I should land a little quicker so that it'll heat up that brake disc. Well, once it's heated up, fine. But it was notorious for getting gravel or such in there and locking up the wheel caliper. Okay?
Is the disc spring-loaded then, or not?
It is not. It is not spring-loaded. It just literally floats in there. That's all. Like literally goes in and out, and it has a two or usually 4 or 5 little bitty blocks, it looks like, in there made into the wheel so that it can't bottom out into the wheel. It just hits those little stops and then back and forth. Okay? So the whole wheel itself was made to move, or slightly move, but really the disc itself was made to float, or supposed to be floating. But as you can tell, they did corrode. And the early ones, what's crazy is this one is actually made later on so that you could remove the disc by getting these little tabs out of the way. Early on, they would actually rivet it 45 times, right, Parker? Is that yours? No. Who? Yeah, you had the oldie goldie right there, the Goodyear original, right?
Oh.
It had like 40 rivets around it. We've already took the disc off, but it had like 40 rivets all the way around the wheel. So every time you had to change the disc, guess what? Those all had to come out. So as I'm building up all the drama and the suspense for Brian, I'm going to move on to the next generation here. So now we have dowels that actually float. Okay? Cute little dowels here, and they float, and the disc is stationary. It's attached to the wheel. And as it moves along, you push on the pedal. It moves this plate via the piston out and squeezes the brake. And then when you let off, guess what? It goes right back away. Okay? So now we have 2 little dowels. Is all that it has to float instead of a giant disc floating. Okay? And then here's our brake disc itself. Can you resurface a brake disc? Nah. We just throw them away once they get to a certain thickness. Quick reference guide will give you the thickness for the brakes assembly, wheel assembly, and the brake disc. And all you do is take that measurement. If it measures it, good to go. If not, then you throw it out and buy another one. Okay? Brake linings brought to you by Rapco. Rapco makes, I'm selling them. No, when you go to Oshkosh, you guys should take a tour of the Rapco factory, okay? Anyway, they make brake linings for all aircraft, and they're put in by little brass rivets. They're super easy to change them just a matter of a few minutes, and they're cheap. Okay. That's all that stops on a single brake disc. Okay, any questions on how a single brake disc system works so far? Okay, this might be the actual picture that you would look at when you're doing your maintenance. So here, number 15, we have the torque plate. Torque plate is attached to what? What do you think, Mr. Peterson? What's this attached to? The wheel. No, not the wheel. Let's pick on someone else for a second. Charlie, what do you think it's attached to, buddy? The axle. The axle. Okay? Versus Goodyear is attached
their whole caliper's attached to the axle, right? So this one, just this torque plate's attached, and then you have these two dowel, they're called dowels, or what is this one called? Number 3, pins, okay? Pins or dowel pins. And all these do is float, okay? It's pretty good practice to put a little anti-seize on there to make sure they keep floating, okay? Just like a car. Then we have our caliper, and there, it's got the piston in it with a back plate, linings, number 5, yeah, pressure plate, and then we get a number 8, a back plate. So then the two linings go on either side and it squeezes that disc. Okay? It is common for the piston to leak out of the caliper. Very, very common. It is common. And so what do? You take the caliper off. You put a little, make sure the bleeder is closed, put a little air in it, boom, blow it out, clean out with mineral spirits, change the O-ring, put it back together, and it's good to go. Okay? Very cheap. I know, automotive world, what do? We don't overhaul calipers anymore. What do? R&R, remove and replace. Aviation, absolutely. Take the O-ring out, change it, back on the road for $3. Well, plus labor. Okay? Any questions? All right, I got 10 minutes, so here we go. See what I got.
We got any videos?
I'm working on it, Cap. I'm working on it. Wow. I'm going to hop to it real quick for you, okay? All right, so this is a typical master cylinder. All right, what do you notice here? Assess the style. You got two master cylinders, one for the right brake, one for the left brake. Okay? And then you have the connection linkage there. All right, the master cylinder then sits there, it's hanging out. Then as you push the brake, now the pedal pushes down on this piston rod, and the piston's here at the bottom. It now takes fluid from the reservoir, or it basically seals off the fluid, and pushes down. Now it becomes the cylinder to push on the brake fluid. Then as it comes up, there's a tiny little space, ever so tiny, between the piston and the spring. That space, according to the Cessna manual, is 40 thousandths of an inch. 40 thousandths. And yes, when you do your master cylinder, I will check every single one of you. Because if you don't have 40 thousandths, it pulls back, it won't refill it. And the brake pedal actually won't come all the way back up. It'll sit just ever so slightly down, because it doesn't have a chance to spring back and then refill it. So every time you push down on the brakes, it will wear just a little bit, but it automatically refills that cylinder, as long as there's fluid in the reservoir. Okay? All right, Zach, just for your enjoyment, we're going to talk about bleeding brakes. Okay, so, all right, no problem, I'm glad you are. All right, so I'm going to go to it. Here's a typical connection on your brake caliper, okay? This is typically where you're going to see, you're going to have your brake line come over to your caliper. Here's our wheel, brake disc, and it's squeezing, okay? So the lab that I'm going to hand out tomorrow will include removing a master cylinder, move your master cylinder, inspect the master cylinder, and the only way we do the inspection on the master cylinder is we literally take this off the pedal, take the top off. Do not take the bottom housing off. Well, let's stop that. Okay, save your time, save your sanity. If you want to if you want to go towards insanity, take the whole thing out. But if anyone ever asks you, hey, you need to do a master cylinder inspection, what they're really saying is pull the cotter pin, pull the pin off the back of the pedal, and pull to do? It just sits there now. It's still attached underneath the floor. But if you want, if you really feel excited and you want to pull the floor, knock yourself out, whatever. So, it has a little, typically they'll have a little Allen or a lock nut in there. You pull the top off, there it is. That's all that stops you. That's all. Even on the full 14, it's the same system. As you push on it, now we get a little bit of movement. Okay? That little O-ring is what pushes down the cylinder. And now if you notice, right here at the top is a little tiny V. Everybody see that? I'm helping you. Here we go. See the V? Right there. Boom. Okay, so as you push the pedal goes down. This pushes down because it has this piston behind, or the actual cylinder piston rod behind it, pushing on the piston. Okay, so now it goes down into the hole and pushes on the fluid because of this O-ring. Okay, when it comes back up, here's what happens. You have 40 thousandths right here, and it pulls down. Do you see that movement? So the spring is always pushing up. Pushing. And then I pull down against that spring. Okay? I need to have a minimum of 40 thousandths between that right there. Okay? As you tighten that nut up, I should have 40 thousandths. Boom. So when I pull it back, so that when the brake pedal comes back up, when Trevor lets his foot off the brake pedal, then this piston pulls back, fluid goes down the little V. Everybody got me? It goes through the hole inside the piston. Goes through the hole inside the piston and refills the cylinder every time. If you tighten it, there's a little O-ring here and a little O-ring inside the piston that if you tighten it, it cannot compensate. The pedal will just sit there and sit there and sit there straight down. It won't ever bounce back because that little spring, 40 thousandths of a mistake. That's it. Got to have that space. It's supposed to be there. And guys are like, man, that seems loose. Yes. And so it refills and you can have brakes every time. Zach, did you know that? Did you know that? 40 thousandths right here. I'll pass it around. I'll pass it just like this. Okay? What'd you say? You're feeling silly right now?
Yeah, I'm trying to understand.
Today we're going to take apart a Cleveland brake. This is off a Cessna 150, but a lot of airplanes are very similar. Here we're measuring the brake disc and inspecting the disc. We took the tire off this wheel half.
What type of wheel is this? Corbin? Yep. Cleveland. Was that a guess? Hey, Greg.
And before we do too much, I want to see what this brake's been through. And my brake disc looks pretty good, a little bit of rust, but that's normal. It's a steel part. So now we've got the brake disc, or the brake caliper here. I'm going to take the bolts off, and I had the other pad, the two pads are bolted on, or the one pad's bolted on the outer pad. Take that off, and I'm going to do a little inspection here. Going to inspect these, and these linings actually don't look too bad. They've got some wear on them. I'm looking at the part that holds the axle mount for this. Now this has got a couple of grooves in it. I'm a little bit concerned about that, so I'll consult the overhaul manual over that. But not too bad. Here I'm pulling the inside lining out, and you can see underneath that's the piston. I'm going to measure this with the calipers, and my numbers are in the book, so I can check that. Here I'm looking at the overall condition of the caliper before I pull it apart.
Which book would you find the thickness for the lining I want you to do as a good mechanic is grab the linings and see if they move. They are brass rivets. Over time, the rivets could get slightly loose. If there's any movement in the lining, just put another rivet in. Or look and see if it's actually cracked around the rivet hole, okay? That's a common thing, is that it will crack around one of those rivet holes right here.
This caliper spent some time in the tank. Okay, here I'm going to take a little bit of compressed air. I'm going to turn my compressor down. I'm just going to give this just a little bit of a blast. Now, be careful because you can get hurt doing this. I turn my air compressor down and I blow the piston loose. And now we get a chance to inspect the piston, the cavity, and the caliper. And I want to see if there's anything broken here, any big scratches, galls. I pop the O-ring off with an O-ring tool. And the next thing is this thing's going to make another trip to the solvent tank. And I'm putting everything, there's a mineral spirits is the solvent that's in here, also known as Stoddard solvent. Taking my brush, I'm going to do a little bit of brushing and a little bit of cleaning, and we're going to get ready to start overhauling this brake assembly.
All right, good deal. So when you're doing yours, you get a right brake. You're going to pull the brake assembly off, inspect the full brake assembly, measure the disc, measure the linings. Then you're going to put it all back together, and then you guess what? At that point, you're going to inspect your master cylinder. Do the inspection of the master cylinder, put it all together as well, okay? And then at the end, you've got to bleed the brakes on the aircraft, okay? And so because I am extremely nice guy, I have posted all kinds of videos with me, yours truly, so like and subscribe. I'm just kidding. But doing the bottom to top and top to bottom. So we'll watch those right off the bat in the morning on bleeding brakes the way that I want you to bleed brakes. It's me talking, so I don't really like listening to it, but we're going to play it during class time right off the bat in the morning on how I want to see you bleeding brakes on the aircraft that I give you tomorrow, okay? Any questions? Yes, sir, Leo.
You take off the caliper and you just cap your line? So does it-
Cap, yep. Now, one trick for the pipers, especially any of the Arrows, Archers, Cherokees. If you're wise, you'll listen and you'll take it to heart for the rest of your life. If you're foolish, you will ignore me at this moment. Okay. If you take the caliper and pull it up in the air, up high, and then break the caliper loose, if you have to do a caliper inspection, say it's weeping a little bit. On the pipers, if you actually pull, because it's a flex hose, pull it up and then J it and loosen it and then cap it while it's still up in the air, cap the line. It will not get air in it. You'll save about an hour to 2 hours worth of work. But if you just get in there, you're like, man, I'm going to hop in here and fix it. And then you just pop it loose, yank it off, and immediately it's sitting there dripping. You're going to have air going up into the system. Okay? So what we say is J it. So you're going to pull the caliper off, poof, still attached to the line, and pull it up in the air and then loosen the nut. Okay? Those of you who've already worked on Piper, you realize how extensive their information is that they give you. Insert the wheel and make sure it's tight. That's it. So there's a lot there that, hey, if you'll listen, it'll save you some time. Yes, sir?
If you were to do that, how would you know if you ended up getting air in the system with that?
Oh, with Piper, you'll always know. The moment you push the pedal and it's spongy, you'll know. Yeah. This sin shall surely find you out. It will know. You will know. Okay?
So the way we did it in the automotive shops, we would actually put pressure on the brake pedal before we took it apart.
Yeah.
That would set the vacuum so it would keep going.
Yep. It's a good idea. You could do that. Best thing, still with a Piper. Yeah, as long as you're in the pilot seat. If you didn't from the pilot seat, you probably put pressure onto it that way. You're going to dump a lot of fluid. So those of you who will do piping this year, you'll realize it. They do inverted master cylinders. So they're doing inverted master cylinders, so when you push on the brake, so air is notoriously getting caught up here in the very top. Because their master cylinders are all upside down. They're hard to get air out of. All right, I'm gonna stop there. We'll hit bleeding brakes tomorrow. We need to move planes today. So